Good day to everyone. Our focus today is the illustration of the squeeze theorem or the sandwich theorem. Suppose that the functions f, g, and h are defined on some open interval containing a, and that your g of x is greater or equal to f of x but less than or equal to h of x, and the limit of f of x and h of x both exist and equal to L, then the limit of g of x exists and it is also equal to L. Now, how are we going to illustrate that one? Meaning to say, when we are going to illustrate this statement, illustration, okay, illustration, that is the same as when in our illustration, when your f of x is considered to be less than or equal to g of x, but your g of x is also less than or equal to h of x, and that it was established that your the limit of f of x as your x approaches a is equal to to the limit of h of x as your x is approaching a, and the result is L, okay, the result is L, then we can also say that the limit of g of x as your x is approaching a is also equal to L. It is also equal to L. So again, notice that our concern in here is the g of x, and that when we establish that your f of x, this one, f of x, the limit of f of x as your x is approaching a, and it is equal to the limit of h of x as your x is approaching a, and they have the same limit that is equal to L, then we can say that the limit of g of x as your x is approaching a is also L. Okay, so that is the squeeze theorem. Okay, so let's try to evaluate the problem. So let's try to see this example. It says in here f of x is greater than or equal to 8 minus x raised to 3, but less than or equal to 8 plus x raised to 3. Now it says in here, find the limit of the f of x. So find the limit of the f of x. Now how are we going to do the problem? So we have in here the problem. We are going to convert this one into a limit function. So we say that the limit of 8 minus x raised to 3 as your x is approaching 0 is of course less than or greater than or less than or equal to the limit of f of x. F of x as your x is approaching 0. But this must be less than or equal to what? The limit of 8 plus x raised to 3 as your x is approaching 0. Okay? Now, how are we going to solve for the problem? Notice that when we are going to solve for the problem, we say that we apply the direct substitution. Direct substitution. Meaning, in here, that is the same as we have 8 minus 0 raised to 3 is less than but equal to what? The limit of f of x as your x is approaching 0 but less than or equal to what? The same substitution. 8 plus 0 raised to 3. And so notice that that is the same as 8. And so your 8 is your 8 is less than but or equal to the limit of f of x as your x is approaching 0. It's the same as the same as 8. And so meaning the limit of f of x as your x is approaching 0 is equal to 8. So that is the meaning of squeeze theorem. I hope you understand this example. Thank you. We have in here a problem in regarding the squeeze theorem. So it says in here f of x is greater or equal to 5x plus 2 but less than or equal to x raised to 2 plus 8. Now it says in here, find the limit of f of x as your x is approaching 0. Now in order for us to solve this one, we convert this one into all limit notation. Okay, so how do we convert this one into the limit notation? We say that we have the limit of 5x plus 2 as your x is approaching, we consider this one to be 2. I'm sorry. We have in here the squeeze theorem, example of the squeeze theorem. Now it says in here, how are we going to get the limit of the function f of x? So our problem is f of x is greater or equal to 5x plus 2 but less than or equal to x raised to 2 plus 8. Now our problem says that find the limit of f of x as your x is approaching 2. So when we are going to solve this one, we are going to convert them all into the limit notation. So that this one must be the limit of 5x plus 2 as your x is approaching 2. It says in here that must be less than but equal to the limit of f of x as your x is approaching 2. Now what about this one? That is the same as less than or equal to x or to the limit of x raised to 2 plus 8. So as your x is approaching, as your x is approaching 2. And so that is how to do the problem. Notice that by direct substitution, we say that 5 multiplied by 2 plus 2 is less than or equal to the limit of f of x as your x is approaching 2. Now by direct substitution also is the same as 2 raised to 2 plus 8. Now doing that one now, that is the same as 10 plus 2, that is the same as 12. 10 plus 2, okay, is less than or equal to the limit of f of x as your x is approaching 2. And what about this one? Less than or equal to 4 plus 8. So that you will notice this is 12 is less than or equal to the limit of f of x as your x is approaching 2, less than or equal to 12 also. Okay, so notice that the limit exists, they are defined, and you notice that the limit of 5x plus 2 as your x is approaching 2, and the limit of x raised to 2 plus 8 as your x is approaching 2 has the same value, that is the same as 12. They are equal, and so we can now conclude that the limit of f of x, the limit of f of x as your x is approaching 2 is what? 12. Okay, so that is the squeeze theorem. That is the squeeze theorem. And I hope you understand the problem. Thank you.